Quantum cryptography and telecommunications. Section 1. What is quantum cryptography and quantum key distribution systems? Quantum cryptography is a method of protection communications based on the principles of quantum physics. The history of quantum cryptography did not start with communication technologies, but with an attempt to solve a completely different problem: to create money that is impossible to forge. In 1983, Steve Wisner of Columbia University proposed creating quantum money that is impossible to copy or forge. The probability of making an exact copy of an original protected by quantum technology tends to zero. The essence of the technology is that each banknote has traps with photons, each of which is polarized in a certain way on two different bases. It was a great idea, but unfortunately not technically feasible. There are still no convenient and affordable mass traps for photons suitable for placement on money. Wisner also suggested that a similar mechanism could be used to create confidential communication channels. A year after the publication of this paper, scientists developed the first protocol for quantum communications, BB84. This protocol is widely used in modern quantum communication networks. Scientists have proposed encoding data in the quantum states of single photons, for example in their polarization. As which are the quantum objects, the very fact of measurement necessarily affect the states of the object. Thus, if someone else tries to eavesdrop on the transmission of photons, that is, to measure the states of the photons that we exchange, we will definitely notice it because the states of the photon will change. Therefore, in theory, it is impossible to connect to the quantum data transmission channel. Notably, in principle, the fundamental laws of quantum mechanics do not allow it. Why this matters? Without encryption, virtually no data transmission is possible today. Encryption methods are based on the following assumption: the task of decrypting messages is so complex that the computing power of an attacker is not enough to solve it. In other words, if an attacker has unlimited computing power, he will break classic ciphers. Back in the 90s, a hacker combined several hundred computers over the internet and broke the RCA cipher. Previously, it was considered that it would take several decades to break this code. Quantum key distribution systems. The principles of quantum cryptography are now applicable to quantum key distribution systems. Quantum key distribution systems have already been generated and are successfully applied. This is one of the most promising areas in the field of data protection. Our laboratory has two active quantum key distribution systems, and the participants of the summer school work with them. According to the track program, you are going to complete several lab classes with this unique equipment. Section 2. Telecommunications. Assembly of the telecommunications rack, optical fiber welding and connector crimping. Now any company uses telecommunications equipment and data transmission networks. Telecommunications network consists of copper and optical components. In today's job market, the most valued are those who know how to design a telecommunication network. These skills are essential in both everyday life and when applied for jobs. As part of the course, school participants are to design a telecommunications network, learn how to deal with twisted pair cable, optical fiber and telecommunications equipment. Participants of the school will learn not only how to weld optical fiber and configure a telecommunications rack, but also how to conduct analysis and testing with high-quality equipment.